We'll be learning about uniform probability distribution in this lesson. And you might have guessed from the name, uniform, that we're dealing with something that has the same probability throughout. So an example of a uniform probability distribution or a uniform probability would be a coin flip, in which case there are two outcomes, heads and tails, and each of these have the same probability. They're both 1/2 if the coin is fair. And similarly, you can think of a die. Right? Each of the numbers on the die have equal chance of 1/6 of being rolled. So these are examples of uniform probability distribution. And these are actually discrete examples. Because again, for let's say we're looking at the die, you can't roll a 1.5 or a 3.7, right? It's either a 1 or a 2 or a 3 or a 4 or 5 or 6. And same with heads and tails. You can either roll a head or a tail. You can't roll anything in between. So these are both discrete cases. But even in uniform cases, or I should say continuous cases, we have uniform probability distribution. And one example of that is a spinner. So I'm spinning this arrow and I'm wondering where this arrow is going to land. And just for simplicity's sake, I'm just going to divide this circle up into 4 sections. Sorry, 0, 1, 2, and 3. So in this case would be a continuous data because the pointer can land in between any of these numbers. It can land right there, it can land right there, it can land right there. Right? It doesn't have to land on the numbers. It can land anywhere in between. So this is an example of a continuous case. But again, these are both uniform because each of the cases, so in this case, landing in any of these quadrants are equally likely. So each of these cases are equally likely. That's why this is a uniform probability distribution. Now let's try to model this probability distribution in a graph. So let's try and do the die problem here. Die problem. So we're going to have the possible outcomes over here. 1, 2, 3, 4, 5, and 6. And each of these are equally likely to happen. It says they're all going to have a height of 1/6. So for 1, it's going to go up to 1/6. 2 also 1/6. 3 also 1/6. 4 also 1/6. 5 and 6. So all of these have a height of 1/6 because that's the probability. And this is the characteristic of uniform probability. The height of each of the events, or the probability of each of the events, are exactly the same. And once you drew this, once you draw the graph, you can check if you have done this correctly. And one way to check that is that the area under this rectangle that we draw, or that we have drawn, should be 1. The area under all of these should be 1. And the area is easy to calculate because this is a rectangle. The height right here is 1/6. The length of the whole thing, it's going 6 units, so that's going to be 6. So when you multiply 6 times 1/6, you should get 1, right? So the area under that rectangle, or area of that rectangle, should be 1. And you can even use this model to find the probability of some event. So let's say the probability of x equaling 5. This would be the probability. In this case, x is going to be the number that you're rolling. And the probability that the number that you're rolling is 5. Right? So that would just be this section right here, this rectangle. The probability that the number that you're rolling is 5 is just the area of that bar here, which is just 1/6. Or you can say 1/6. The height is 1/6. The length is 1. So 1/6 times 1 is just 1/6. And you can also do this with inequalities. So probability that x is less than or equal to 3. Which means the probability of rolling a number that is 3 or less than 3. So looking at the graph, this would be 3 right here. And less than 3 would be this whole section here. So this area would be the probability, or it would give us the probability of rolling a number that is less than or equal to 3. And that is just going to be 3 times 1/6, which is 1/2. Right? That's 3 units on the bottom and 1/6. That's the height. And you can even do this with 2 inequalities. So the probability that you roll a number that is greater than 2 but less than 5. Probability of rolling a number greater than 2 but less than 5. It's greater than 2, and it's strictly greater than 2, which means it is not including 2. It's starting from 3. And then it's strictly less than 5. So it's not including 5. It's greater than 2, but it's less than 5. So it's going to be this section right here. So the probability of that would be this 2 this way and 1/6. 2 times 1/6, which is 1/3. Okay, so I think this graph is a good way to visualize how you get the probabilities. And we can do the same thing with this continuous case on the right with the spinner. The only difference is when we label the horizontal axis here. So here we have 4 quadrants. Let's say Q. 4 quadrants. And these quadrants are really what's important. So we have to make sure that we have 4 quadrants. Right, so the first quadrant here, first quadrant is between 0 and 1, right? So that's going to be between 0 and 1. The second quadrant is between 1 and 2. Third quadrant here is between 2 and 3. And the fourth quadrant is between 3 and 0. But since this is a horizontal line, I'm just going to put a 4 here. We can imagine that there's a 4 there and say that that is between 3 and 4. And before we find the probability of each of these, let's first draw the rectangle. So a rectangle is going to be something like that. And if you remember our rule, the area of this rectangle, the area of this whole rectangle has to be 1. So if this area is to be 1, what should our probability here be? So the length here is 4. 4 times what? 4 times what gives us 1? And if you know basic arithmetic or algebra, you'll find that that would be 1/4. So that would be the probability of the arrow landing in each of these quadrants. The probability of landing in the first quadrant would be the area of this right here, which is going to be 1 times 1/4, which is just 1/4. And again, we can notate this using our probability notation. So probability that the arrow will land between 0 and 2. Okay, so 0 is right here, 2 is right here, so the probability that it'll land in between 0 and 2 is going to be the area of this rectangle right here. So that is going to be 2, length is 2 times 1/4, which is 1/2. And that makes sense also looking at our spinner diagram here. Probability that the arrow will land somewhere in this region, right? We're talking about 0 and 2. That's exactly half. So that's why our probability is half. Okay, so this is what uniform probability is. The important thing is that the area, or that it has to be modeled with a rectangle because all the probabilities are the same, and that the area of that rectangle has to be 1. Okay, so remember those things, those two things about a uniform probability distribution. And of course, using that diagram, you can find or solve for probabilities of different situations.